Hi students, let's continue with the learning curve. So in the first video, I explained learning curve calculations in the tabular method. Then we looked at the equation, the algebraic method. Now there is something called learning maturity point. Learning maturity means, hold on, what's the meaning of learning? People become faster when they are doing a task. Repeatedly, when they do the same task, they become faster. But there is a limit. Once they reach the maximum limit, maximum speed, then the learning does not continue anymore. So if a question comes with learning maturity point, how we are going to analyze that? I'll show you with an example. First unit, say 20 hours. Learning curve 90%. Learning stops after 10th unit. That means up to 10 units you have learning. After that there is no more learning. Find the total time for first 15 units. So concentrate. You have starting to 10. These 10 units you have learning effect. Then up to 15, the next 5 units, no learning effect. In this region, no learning. Here, learning. So the formula that we studied can be applied only up to 10th unit, not after that. Because when there is learning impact, learning effect, you can apply the formula. Alright, so 1 to 10 units, let me analyze separately. Y equals AXB, first unit 20, you are applying for 10 units. B, from this I can find B, log of 0.9 divided by log of 2. Log of 0.9 divided by log of 2, 0.9 log divided by 2 log minus 1520. Okay. So 20 multiplied by 10 to the power of minus 1520. That gives you the average time, 14.09. So 10 units total time I can get. Total time for first 10 units. 14.09 is the average. I want total, so multiply by 10. That is 140.9 hours. 140.9. Now, the next 5 units, how do we do it? Since learning has stopped with this point, every unit thereafter is going to take the same time. Same time as of which one? As of 10th unit. Repeat, after 10 units there is no more learning. That means 10th unit's time, 11th unit's time, 12th unit's time, 13th unit's time, 14th unit's time, 15th unit's time, every unit takes same time. No more learning. So up to 10 anyway I have included in this calculation. This says 1 to 10. After 10, how many units are there? 5 units. Which ones? 11th, 12th, 13th, 14th, 15th. So how do I find the time of these 5 units? Find 10th unit's time and multiply by 5. Because 10th is already included here. Only 11, 12, 13, 14, 15. 5 units. Question is, how do I find 10th unit's time? 10th unit. Not so difficult. 10th unit's time is total time for 10 units minus total time for 9 units. Right? Find the time, total time up to 10 units, total time up to 9 units. The difference will be 10th unit. Suppose if they ask 20th unit's time, total time 20 units minus total time of 19 units. If they ask 100th unit's time, total time of 100 units, total time of 99 units. That's how you find it. So 10 units total time, we already found it. Our working has it here, 140.9. 9 units time, how do you find it? First we will find the average. Y equals A. How much was A? A was 20. 9, 1520. 20. Straight away we can get the answer. We have a calculator. 29 to the power of 176.96. Am I right? Oh, no, wrong. I didn't put the power. So 29 to the power of minus 1520. That's 14.32. 14.32. So total time is going to be, first 9 units, total time will be 14.32 into 9. 14.32 into 9. 205.06. 205.06. Something is wrong here. How comes this is 205.06? I missed it. 14.32 multiplied by 9. 14.32 multiplied by, where is this 0 coming from? 14.32 multiplied by 9. 128.88. This has to be 128.88. So here. Once again, look at the overall working. This is the time for 10 units. This is the time for 9 units. The difference is 10th unit's time. Answer 12.02. 12.02 hours. This will be the time for every unit after 10th unit. So from 11 to 15, it's going to be 12.02 for every unit. 5 units like that, 60.1 hours. 60.1. So 1 to 15 total time will be 1 to 10, we got the total as 140.9. Then the next 5 units 60.1. Altogether 201 hours. 201 hours. Clear? So this is how we deal with learning maturity point. Right. Now let's go back to the slides and see what points are there in the slides. This we have seen already. Learning curves. General idea, the more you do something, the faster you become at it. As cumulative output doubles, this is what I wrote as cumulative total production doubles. Cumulative average time per unit falls to a given percentage of the previous average. Requirements. If learning curve comes in an essay question, this can be tested as a theory question. What are the conditions for learning curve to apply? It must be manual element. Again, I am telling, in the modern world, in today's world, machines are learning. There is machine learning. Artificial intelligence is there. Learning curve may become applicable to machines also. But by the time when this syllabus was developed, when this book was written, it was, the learning curve effect was defined mainly for manual element. We assumed machines are not learning at that point. Task must be repetitive. If you do different tasks every day, then you don't have a learning impact. Early stage of production, that means if the production has already been done for some time, then all the learning curve would have finished. When do you see learning impact? At the early stages. That is why learning curve questions, when they are starting, they will start saying XYZ company has developed a new product. Why they say new product? Because at the early stages only you can find this learning impact. Consistency in workforce. That means if you have high labor turnover, if there are new laborers being joined frequently, then the learning curve will not continue. Meaning, one person learns and he becomes faster. A couple of days he leaves. A new person joining cannot continue at the same learning curve where he stopped. He will start fresh. So the learning curve impact, same work, same working conditions, same machinery, same material, same people must be doing it. No breaks in production. See, for example, Monday to Friday you are working and Friday you reach a particular speed. Then when you take the weekend break and come back on Monday, of course you may feel fresh. However, the speed that you were gaining by working continuously, that might drop. On Monday morning you might be a little lazy. Or even think about day break. A day you are working faster. By the end of the day, next day when you are starting, you may not continue at the same speed. So breaks in the production. Plus motivated workforce. If the workforce is not motivated to learn and work faster, either they must have incentives to work faster or they must have some self-motivation, then only the learning impact applies. So these are some of the conditions that applies for learning curve to be applicable. And this is the popular learning curve graph. Cumulative average time on the y-axis, cumulative total production on the x-axis. The graph goes down. Let me show you two graphs. This is for 90% learning curve. This is for 70% learning curve. Do you understand? The learning curve 90% means the drop is less, right? Only 10% drop. So the graph will be more shallow. Whereas if the graph is 70%, it's more deeper. Equation I already have showed you. Steady state. Steady state means after the learning maturity point. Can you see in my graph up to here it reduces, then it almost constant, right? Constant means steady state. Steady state means what? After learning maturity point has been reached. Theory: as cumulative output doubles, the cumulative average time per unit produced falls to a fixed percentage of the previous average. When does learning curve theory apply? Labor, brand new or relatively short-lived products, complex product. See, if the task is more complex, then there is more room for learning. Then you will become faster. If it is a more straightforward, simple process, there is nothing much to learn. You will not be able to observe the learning curve effect. So, complex product made in small quantities. The tabular approach, you can see production doubles to 4, 8. Look at the average time, cumulative average time, 90%. Yeah, then you can find the total time and everything after that. Hope you understand this one, incremental time. That means first unit has taken 50. Then for 2 units, 90 means how much is the extra? 40. So second unit has taken effectively 40 only. First unit, 50 hours. Next one unit, 40 hours. Then 2 becomes 4. So you have made another 2 units, right? That extra 2 units, how many hours it has taken? Look here. First 2 units, this is the total, 90 hours. First 4 units, 162. So what's the difference? 72 hours is the time taken for 2 units after second unit. That means 3 and 4. Then 5, 6, 7, 8, next 4 units, you can get the difference here and get it. That's the incremental time taken. Note that cumulative average time per unit for all units produced so far, back to end and including the first unit. That's what I said. From the very first unit, you have to count it. You cannot start counting from the middle. Formula, we have already seen this formula. Costs affected by the learning curve effect. Only labor cost and other variable costs directly depend on labor. Of course, this is connected to labor hours. So any cost that is connected to labor hours will have impact. Materials should not be affected unless early on the learning process they are used inefficiently. That means at the very early stages, people might inefficiently use material, but after they become experienced in making the product, the waste stages, the mistakes may not be arising. So materials also, there might be a saving. Fixed overhead expenditure should be unaffected, because that has nothing to do with labor hours. However, some problems might be caused in an organization that uses absorption costing. Let's not go into that in detail, absorption costing. Where learning curve theory can be used. This was tested in the past exams. Explain the benefits, explain where and where learning curve can be applied to calculate marginal cost of making extra units. See, let's say you are already making 10 units. Now you are getting a special order for another 2 units. Another 2 units. Special order. So you want to give it at the low price. So you can apply the learning curve and find out for these extra 2 units how much extra labor is going to be consumed. That's the meaning of marginal, right? Incremental. When you make extra units, how much is the extra cost? To quote selling prices for a contract where prices are calculated at a cost plus percentage markup. Because labor cost you are going to find using learning curve. So wherever cost is needed, cost plus pricing is needed, you can apply this to prepare realistic production budgets and more efficient production schedules. If I go back to the example, can you see here? Let's look at the first 10 units in this example. First unit took 20 hours. So somebody who do not have the idea of learning curve will think every unit thereafter is going to take 20 hours. So if 10 units are budgeted, he may give a budget allocation of 200 hours. But after applying the learning curve, I understand it's going to be only 141 hours, 140.9 hours that's required. So imagine instead of 140.9 hours, if I give a budget allocation of 200 hours, how much extra time I'm giving? Almost 60 hours of extra time I'm giving. 2 easy budgets where the laborers are going to relax. Even if they relax and do it, let's say they finish the work in 175 hours, they relax very well, comfortably they achieve the targets, still better than the target, they are going to get the bonus also. So like, this is not effective, not efficient. So production budgets will become realistic. The standard costing, when you set labor standards, how much of time should be taken, how much is going to be the cost of the product, all that will be realistic. So these are advantages, why we must consider. This was tested once the other way. What are the implications if learning curve is not considered? So you can say cost will be high, because of that prices will be high. So in the market you will be non-competitive, you will be losing to your competitors. Third, you can say your standards are wrong. Standards are wrong, that means laborers will be relaxing and achieving the targets. Limitations, you know, we set certain assumptions here, where this one, all these are limitations. Why all these are limitations? Large manual element. So you can say if the workload is not manual, if it is not labor intensive, learning curve will not apply. Repetitive. In the modern world, we focus more on flexibility. That means we are trying to customize the product for each customer group. We don't exactly do the same thing again and again. So this concept of repetitiveness is affected by that. Early stage of production, that may be okay. Consistency of workforce. People leave, then things might change. So all these points you can even mention as limitations. However, let's see what are the points highlighted here. The effect is not always present. Some products are too simple, you don't see learning curve effect. It assumes stable conditions which allow learning to take place. That means same materials, same machine, same working conditions, same workers, same task. Then only you can apply learning curve. But in reality, it may not be the same. It assumes a certain degree of motivation. That was one of the points earlier also we saw. If the labor force is not motivated, then you can't observe learning curves. Breaks between We already saw that if there are breaks, then the learning. So if you look at the graph, how the graph will happen, you work like this. At this point, you take a break. After the break, it goes like this. Again a break. So you will not have a continuous learning curve. It may be difficult to obtain accurate data, decide what the learning curve is. For example, 70%, 80%, 90%, where a company's workforce stands might be very difficult to accurately predict. Learning will eventually cease. That's the maturity point. Learning doesn't continue indefinitely. Steady state I already explained, that means after the learning maturity. Right, let's answer these questions. A firm's workforce experiences 75% learning curve. If the budgeted time for the first batch is 100 hours, calculate the time to produce 8 batches in total. All right, 1 and 8, we can get it by doubling. 1, 2, 4, 8. Cumulative total time, cumulative average time. First one, 100 hours. Next one, 75. One by one, I don't have to find it. I can straight away find to the last one. How? Once, twice, 3 times you are going to multiply by 75%. So it's going to be 100 into 0.75 3 times. Power 3. 100 into 0.75 power 3. 42.875 hours. That's the average. Multiply that by 8. Multiply this by 8 to get the total. 337.5. Check the answer. They are doubling. They are doing one by one, but don't waste your time in the exam finding each of these answers. Useless. So I would suggest take 100, multiply by 75, 3 times. So you can write it as 100.75 to the power of 3. 3 times you are multiplying. Question. 75% learning curve. Budgeted time for first batch is 100. First 10 batches in total and 10th batch only. 10 batches in total. Let's find the average. 100, 10, 75% learning effect I need. Learning index. Log 0.75, log 2. Because 10 doesn't come in doubling. If you start from 1, 2, 4, 8, 16. 10, I have to apply this formula only. 0.75 divided by 2. 0.75 log divided by 2 log minus 0.415. Yes. So this answer is going to be, this is average, 100 multiplied by 10 to the power of minus 0.415. 38.46. That's the average. So total will be 384.6. How? Multiply this by 10. Okay. For 10th batch, what I need? I need 9 batches total. 100, 9, 415. That's going to be 100 multiplied by 9 to the power of minus 0.415. 40.18. So total will be 40.18 into 9. That's for 9 batches. 40.18 into 9. 361.62. So this is 10 units total. This is 9 units total. Get the difference. That's going to be 10th batch. 384.16. No, 384.6 minus 361.62. That's going to be 22.98 hours. 22.98 hours. Can you see? Small rounding errors could be there. 22.98 we got. 22.99 is here. Another similar question is there. You can try this and the answers are here. check that, and if you have any doubts, feel free to get back to me. Thank you. So that's all in terms of analytical techniques. We have studied high-low method, regression analysis, time series analysis, and learning curve. Now we can continue with the rest of the budgeting and standard costing in the next part of the video. Thank you.